The ice giant has always been the odd one out, a pale, cyan marble rolling on its side through the freezing dark of the outer solar system. For decades, Uranus kept its secrets wrapped in a thick haze of indifference. When Voyager 2 sped past in January 1986, it sent back snapshots of a seemingly featureless world, a billiard ball that stood in stark contrast to the turbulent storms of Jupiter or the ringed majesty of Saturn. But the silence of Uranus was a lie. Hidden within its dark, razor-thin rings and orbiting just beyond the reach of our oldest instruments, a secret population of satellites has been waiting. Astronomers call them the ghost moons, tiny, elusive worlds that have evaded detection for 40 years, revealing themselves only through the faint gravitational ripples they leave in their wake. The story of their discovery is not just about finding new rocks in space. It is a detective story that spans generations, from the grainy data tapes of the 1980s to the golden mirrors of the James Webb Space Telescope. It is a tale of reawakening our interest in the most neglected planet in our solar neighborhood. To understand the ghost moons, we must go back to that fleeting moment in 1986. Voyager 2, NASA's legendary probe, was executing its flyby of Uranus. It was a brief encounter, a blink and you will miss it moment in cosmic time. The probe discovered 10 new moons and 2 new rings, confirming that Uranus was not as lonely as it looked. But Voyager's cameras, cutting edge for their time, had limits. They could spot the large icy moons like Titania and Oberon, and the mid-sized ones like Puck. However, in the chaos of the ring system, a complex network of dark dust and boulders, anything smaller than a city was lost in the noise. For 30 years, the data sat in archives. It was not until 2016 that planetary scientists Rob Chancia and Matthew Hedman from the University of Idaho decided to take a second look. They were not looking for moons directly. They were looking at the rings. Rings are not solid structures. They are rivers of flowing ice and dust. And like a river, they ripple when something disturbs them. When a moon orbits near a ring, its gravity tugs on the particles, creating a pattern called a wake, similar to the V-shaped wake a boat leaves in water. Chancia and Hedman noticed something strange in the alpha and beta rings. There were periodic variations in the ring density, wavy patterns that could not be explained by the known moons. The mathematics of the ripples pointed to a single conclusion. There were invisible objects, just 2 to 9 miles wide, orbiting just outside these rings. These were the first ghost moons. They were too small and dark for Voyager to see, yet their gravity was strong enough to sculpt the rings, acting as shepherds that kept the ring particles in line. For years, they remained theoretical, mathematical ghosts haunting the data. But the ghosts did not stay invisible forever. The launch of the James Webb Space Telescope ushered in a new era of clarity. With its powerful infrared vision, Webb could pierce through the glare and the gloom that had blinded previous telescopes. In 2025, the theory became reality. Turning its golden eye toward the 7th planet, Webb captured a series of long-exposure images that revealed a faint, moving dot that should not have been there. Designated S2025U1, this new moon is a tiny world, roughly 6 miles or 10 kilometers in diameter. It is the first new moon discovered around Uranus in over 2 decades, and it fits the profile of the ghosts perfectly. It orbits within the chaotic inner zone, a region so packed with debris and moonlets that astronomers describe it as the most densely populated orbital highway in the solar system. The discovery of S2025U1 was a vindication. It proved that the Uranian system is teeming with micro-moons, objects that blur the line between a large ring particle and a small satellite. It also suggested that the alpha and beta ring wakes identified in 2016 are indeed caused by similar, yet-to-be imaged bodies. However, finding these moons has led to a darker realization. The Uranian system is violent. Most of the small inner moons of Uranus belong to a cluster known as the Portia group. These satellites, including Bianca, Cressida, Desdemona, and the newly found S2025U1, are packed together so tightly that their orbits are inherently unstable. Gravity is a relentless master. As these moons pass each other, they exchange tiny amounts of energy. Over millions of years, these nudges accumulate, pushing their orbits into intersecting paths. Recent simulations suggest that the ghost moon Cressida is living on borrowed time. Its orbit is slowly warping, and within the next million years, a blink of an eye in cosmic terms, it is destined to collide with the moon Desdemona. This will not be a gentle merger. It will be a cataclysmic smash-up at thousands of miles per hour, pulverizing both moons into a cloud of ice and rock. This debris will form a new ring, which will eventually accrete into new, smaller moonlets. This cycle of destruction and rebirth explains why Uranus has such a strange dark ring system. The rings we see today are likely the graveyards of ancient ghost moons that smashed each other to pieces eons ago. We are watching a slow-motion demolition derby where the contestants are entire worlds. The mysteries of Uranus are not limited to its moons. The ghost moon hunt has also forced scientists to re-examine the planet's bizarre magnetic field. Voyager 2 famously observed that the magnetic field of Uranus was chaotic, tilted 60 degrees away from the rotation axis of the planet. For decades, this was thought to be the permanent state of the planet, a tumble-and-roll magnetic mess. But the same reanalysis of data that hinted at the ghost moons also solved this magnetic riddle. It turns out Voyager 2 had incredibly bad timing. Just days before the flyby, a massive solar wind event had smashed into Uranus, compressing its magnetosphere and distorting the data. This means the normal Uranus might be much calmer than we thought, potentially allowing for subsurface oceans on its larger moons, Titania and Oberon, to remain liquid. If the magnetic environment is stable, it increases the chances that these moons could harbor life deep beneath their icy crusts. The ghost moons, orbiting closer in, would be the front-row spectators to this hidden aquatic potential. The discovery of S2025U1 and the confirmation of the ringwakes have lit a fire under the planetary science community. We can no longer be content with 40-year-old data and distant telescope images. The 2023 to 2032 Decadal Survey by NASA has placed a Uranus orbiter and probe as the highest priority flagship mission. The plan is ambitious. Send a spacecraft to orbit the ice giant for years, dropping a probe into its atmosphere to taste the ancient gases. Such a mission would do for Uranus what Cassini did for Saturn. It would map the ghost moons in high resolution, turning them from pixelated dots into real places with geology, canyons, and craters. It would watch the rings ripple in real time, perhaps even catching a moonlet in the act of forming or dying. Why should we care about tiny rocks orbiting a planet 1.8 billion miles away? Because Uranus is the archetype of the most common planet in the galaxy. Exoplanet surveys tell us that ice giants are everywhere. By understanding the ghost moons of Uranus, how they form, how they die, and how they shape their rings, we learn the biography of half the universe. The ghost moons are reminders that even in the empty spaces of the map, something is always there, waiting to be found. They are the silent sentinels of the outer dark, and for the first time in history, we are finally seeing them step out of the shadows.